So my name is Scott Baker. It's my opportunity today to speak to you about why virtualization changes everything. Not so much that virtualization changes everything, but the very fact that you're here and the very fact that virtualization is important to you as both an IT individual as well as your company is the indication that change occurs within the data center. And virtualization just simply is the medium upon which you can enable that change. So while I'm sort of still focused a little bit on the lighter side off of the pathetic reference to making you stick out the name, scale down effect, I think that Scott Adams did a pretty amazing job about capturing the lighter side or the humor behind virtualization. And it's almost as if the moment that syndication picks up on something, it sort of becomes relevant or it becomes actual within the industry. So my absolute favorite is the final segment here, where one of the phased approaches is to hire a series or a team of blind primates to randomly walk through the data center and begin to turn off machines until people complain. I don't know about you, but I can specifically make references to times when I've done that myself. Gone through because I don't think anyone's using this, turn it off, and for 2 weeks it just sits there, virtualize whatever's on it, and I move on. I've not quite made it to this final step where I would take those same monkeys and let them start hurling software at the virtualization infrastructure to broaden my virtualization footprint. So that said, let's talk about the agenda for today. So I do want to focus on how virtualization changes the things that we do and the way in which we do it. Because I am on company time, I will have to spend some of that talking about some of the specific NetApp features and functions that enable that. But I'd like to start first by focusing on the infrastructure selections that we make, and that infrastructure has to be very dynamic in nature. One of the tenets about cloud-based computing as a whole is the elasticity of the infrastructure, the ability for you to burst out and come back in as seamlessly as possible and as simply as possible. I think VMware has done an amazing job at that kind of an idea, and they've broken down the categorical adoption of virtualization into 5 basic buckets. Now, where you may fit on the bucket may be different from the person sitting next to you or the company that you may compete with, but they tend to be pretty much the same each way. There's this initial stage where you're sort of separating out the notion of using physical-based infrastructures and moving into virtualization. This is more of a let me get my feet wet kind of an approach. Let me take some projects that have no relevance to the way that the business operates and try out virtualization. I may choose to deploy different kinds of hypervisors. I may choose to deploy different kinds of applications just to see the effects of virtualization on how the application operates, as well as the proficiency of the staff. In doing that, what I can begin to do is help train that staff and move that staff forward into how virtualization can be used to make the data center more effective. And at this point, this is kind of where we reach that first obstacle in the adoption of virtualization. If we consolidate the low-hanging fruit, if you will, those utility or those file servers into our virtualized infrastructure, what happens next, or what we would go after next naturally, would be the applications themselves. And that's when you start getting into that really sensitive area where the application owner once guarantees that the application will in fact continue to perform the way that it does now in a physical infrastructure. So that's where this notion of aggregation occurs, the ability for you to develop and deliver capacity on demand to support the applications without sacrificing those SLAs, right? So that's a big challenge, and probably of all of the 5 steps, the one that I would say is where people spend the majority of their time, because as you begin to attack the different tiers of applications within your own data center and virtualize them, you have to constantly prove yourself as an IT shop. You have to constantly prove yourself as an IT individual, and you constantly have to prove that the infrastructure that you've chosen, that the company itself has placed its investment into, can support virtualization of applications. And once you standardize on the kinds of servers, getting over that 80 percentile hump and getting into what's next, whatever this magical thing is that we call cloud computing. There are so many definitions to what cloud computing is. I'm not even going to try to summarize it for you, but it is this next magical area that we'll get into that simply pulls us into a situation to where we can standardize not only on the kinds of components that we use to develop and deploy virtualization, but also the way in which we deliver it. Things like automation, orchestration, workflows, et cetera, things that allow us to not only burst out and into off-premise-based cloud environments, but doing so with a hypervisor layer that's capable of bursting back in when that burst opportunity is over. Doing that implies that you've made specific design decisions around that infrastructure, where the focus and the components that support your data center are based on things that are very dynamic. They're very flexible and very agile. Now, from a storage perspective, we've seen basically the same thing. During that separation in that categorical phase there, we see a reliance on direct attached storage. From that, there was this movement into file-based or SAN-based storage to continue to broaden that footprint. When it came to the aggregation or the just-in-time capacity availability, we saw people moving into pools of storage where the kind of disk on the back end largely becomes irrelevant. Instead, I want to have an aggregate collection of data that I can pull from, or storage that I can pull from, that I can then add to the virtualized infrastructure and use it as I need. So if my argument holds true that the majority of folks tend to be in this aggregation phase and that this particular phase tends to be the longest phase, from a storage perspective, where do we go from here? Now, VMware would tell you that things like vCloud Director, vOrchestrator are going to be the tools that are going to enable you to burst into this cloud kind of mode, this cloud kind of an approach. So what about the components themselves? So one of the things that I want to talk to you about today is the notion of a clustered shared storage infrastructure. And I'll do that in reference to some very specific capabilities from NetApp. I'm going to use a couple of slides. So if you're a NetApp customer, if you're familiar with NetApp products, you may see some of these slides that are very familiar. You stick with me because what I will do is show you some things that are relatively new, things that are game changers in the way in which NetApp approaches storage to support virtual infrastructures. Because at the end of the day, what really changes your efficiency, what really changes your ability to make virtualization the catalyst for moving your organization into this new paradigm, and oh, there I did it. So I'm going to need a volunteer that's going to help me with buzzword bingo. I apologize for that. I'm trying to strike paradigm from my repertoire. But to get you into that next point, you're going to have to make very key and very specific design choices, not just at storage, also at your networking layer, also at your compute layer, and the kind of hypervisor that you ultimately decide to use. These kind of design choices that you're going to make are going to ultimately put you in a position to standardize. When you can standardize the way in which you deploy these resources, and you make choices around infrastructures that open up or provide frameworks for you to engage with them at a very pragmatic layer, then you can begin to codify these things into forms of automation. Okay? So how do we get there? Getting there is really a three-step process. So unifying connectivity. What I simply mean by unifying connectivity is you need to make sure that from a storage perspective, from a compute perspective, and from a networking perspective, the components that you decide to use do not provide limiting factors for you. If you want to run a mixed shop that's both block and file, you make sure that your storage array provides NAS and SAN-based capabilities. If you have an infrastructure, a networking infrastructure that requires very high bandwidth methods of communication, you may want to make sure that whatever IP sort of extender or fabric extender or switch networking infrastructure provides you the right kind of connection points to drag the storage at the speed at which you need it to support the compute environment upon which your hypervisor relies. So when we're able to unify that infrastructure, we're able to eliminate silos. And that's ultimately the goal. The silos that you deal with, the obstacles that you deal with, are essentially based on the limitations of the infrastructure that has been decided on. So from a storage perspective, I'd like to introduce you to a concept that NetApp has called the Flexpod, where the key term here is flex, meaning that there's flexibility in terms of how you use or how you deploy the different components that make up the infrastructure stack. It is based on validated technologies from industry leaders like Cisco and from VMware. It is a single storage platform, so it is built on top of the UCS line. It takes advantage of the Nexus line as well from a storage perspective, and relies on NetApp to provide the storage under the bottom. From an integration perspective, because we're using the components that I've got listed here, they do offer the open framework. You can actually integrate this into your current business process management tools if you so see fit, or purchase third-party tools that match better the way in which you manage your infrastructure stack. As we talk about storage, I'd like to introduce you to the line of storage that NetApp offers that support the Flexpod infrastructures itself. And the key that I'd like to make sure that you take away from this is the fact that regardless of whether you use NetApp's virtual storage appliance or this full-up, top-of-the-line enterprise-class array, every feature available is on every platform. So let that sink in for just a minute, because I initially said that the way that you standardize or the design choices that you make ultimately determine the success of how you move through that virtualization adoption cycle. So if every feature is available on every array, the impacts to the operational effectiveness of your staff is minimized. The way that you would provision and protect storage on one array is the same across the spectrum. If you can standardize and codify the same kind of array in terms of how you provision and protect that, then the ultimate result is that you can then craft automation to allow you to provision the storage the same way each and every time. Now, if you've made purchase decisions that are outside of the NetApp family, fear not. Like any good storage vendor, we want to make sure that we have a way to provide you with these efficiencies that I'm about to talk about and these capabilities, regardless of the array that you purchased and have in your data center today. So it's great that I just did the product portfolio pitch. That's awesome. It's no different than what you've probably heard before or seen on YouTube or seen in product slicks. So how's that different? How does that get us into this notion of a clustered and shared storage array? I haven't really showed you anything above and beyond getting you to the aggregation stage in that initial deck. So what I'd like to do instead is I'd like to show you this notion that NetApp is taking, this forward direction that we're moving to, that they refer to as C mode. Now I like to refer to it as cloud mode storage. They'll call it clustered mode. I'm sure they'll settle on some kind of a name at some point. But at the end of the day, what we're talking about here is the separation of the logic that controls the metal underneath it from the metal itself. Now, when we can do something like that, when we can encapsulate the logic on how data is accessed and managed, and do that in a virtualized way, then we've just opened up a whole new mode of clustering independent arrays together to present to you an aggregate array set upon which this virtualized logic exists. So if you're paying attention, you would say to yourself, that iconography looks very familiar. You're right. So the focus that NetApp has is to do for storage what VMware has done for servers. Okay? Let's face it, it was a good idea. It's a solid idea. Look at the industry that we're in today because of it. So let's do that at the storage layer. Why? Because the moment that you can do that, you get into a position where you can begin to scale out, scale up, scale down, scale in. So this elastic nature that I had talked to you about, this core tenet for cloud-based computing becomes a reality. Okay, so my ability to add capacity on demand or pull it or refit it to make it do what I need it to do without affecting the end users that rely on it becomes something that I can achieve. And when you wrap up all of the other things that I had mentioned that have to do with being able to create moments of automation that I can roll into an orchestration tool, then it really changes the game dramatically for products like vCloud Director. Now, to be successful at this layer, it's one thing to be able to separate that logic, but you have to ensure that the logic itself contains within it the efficiencies that the physical environment does as well. Now, at NetApp, metal for us is simply just a means for you to scale. The fact that I call this a FAS 6280 just indicates to me the kind of controller pair and the number of disks that are in it, nothing else. The data ONTAP system itself contains within it all of the logic for which NetApp is based. And that's why we're able to separate that out. The fact that it's a Dell server, an HP server, an off-the-box generic white server is largely irrelevant because we rely on VMware vSphere to aggregate those resources up and allow us to more effectively utilize those resources to serve whatever virtualization action it is that we're after. And the same thing can be said here. So there are a lot of efficiencies that I've got listed here that are built in, and I just want to hit on a couple of them. So the first one is about deduplication. First one is about making sure that you're getting the most out of your data, the most out of the storage, and making sure that it is efficiently laid out in such a way so that you're not constantly having to buy more. Now, your users themselves see a Word document, but under the cover, in reality, it's just a bunch of ones and zeros. So if that Word document gets stretched out across your infrastructure stack, you've just increased your backup times, you've just increased your backup footprint, you've just increased your storage footprint, etc. By identifying blocks that are common and still reserving or preserving the blocks that are unique, we can shrink down what's required of the physical footprint on the disk. But at the same time, we can still provide an experience to the user that's no different as if 15,000 copies of the same Word document to ask you to come to a party at someone else's house still sits inside of your data center. So deduplication at the disk layer is great because it does reduce that footprint, right? But what about moving that up level just a little bit? So NetApp has like all storage vendors, has a read and a write cache. So one of the things that we can do is actually take that deduplication capability that I just mentioned and apply that to the cache itself. So what does this mean for you? So the value for you is that by having an intelligent caching system, the first and foremost advantage that you have is user access or client level access occurs at the cache layer. Whether it's level 1 or level 2, and we'll get into that in just a moment, is irrelevant. The fact is that you're providing access to the data in question as quickly as possible instead of tracking that all the way back to the slowest point in the stack, which is the spitting media. The deduplication itself just ensures that you're not filling up the cache with copies of the exact same information. You're just asking the clients themselves to follow a link that points them to the unique blocks that make up the information that they need, combined with the common blocks that everyone is accessing. So what does this look like from the perspective of the people who use it? Our application administrator doesn't really care about how the storage is utilized. I mean, I think we can all appreciate that. They don't care that the budget doesn't allow us to grow storage out to infinity. All they care about is they need the storage and want to make sure that the storage is available to them. So when they contact their VM administrator, the VM administrator just simply says, okay, I'll spin up a virtual machine with this much storage for you, and may take advantage of technologies like thin provisioning so that the client thinks they demanded 250 gigs, they've got 250 gigs, but I'm only going to allocate 25. I'll give them more as I need to based on policies. As far as the storage admin is concerned, he's just had the VM admin come to him and say, I need all of this space. When the storage admin provisions that storage out, then I'm just allocating disks. I can use physical thin provisioning as well on my arrays and continue to drive that footprint down as much as possible. Now, depending on your colorblind tweakness, I'm using colors that indicate purple on one side, green on the other. And this pathetic PowerPoint attempt here is to show you that the data is the same. The application owners themselves are running multiple instances of the same application, sitting on top of a data store from your VMware administrator who's collecting the same information just in different locations, upon which the storage admin is provisioned storage and collecting duplicate information as well. But a technology like deduplication on our arrays will shrink that storage requirement down. So deduplication is one key feature. The second key feature that I want to talk to you about is how we protect that data on disk. And I don't mean replication. I want to talk specifically about how we protect the data from a RAID perspective. I would hope that you would agree with me that the kind of RAID that you decide to use in your environment drives what you can do with the data that's going to exist within it. Ideally, everybody wants the combination. I don't want to pay the penalty of something like a RAID 10. I want the resiliency of something like a RAID 6, and I want the performance of RAID 6, but I want it all at a RAID 5 offering. So I've just introduced 3 of a myriad of different RAID types for which now my application instances or my virtual machine instances are going to have specific performance characteristics based on the RAID set that I've created on top of the disks that I have available with enough capacity to do whatever it is I need to do. So one of the things that NetApp offers is this notion of RAID DP, double parity RAID, where you do in fact get the value of RAID 10 in terms of performance. You get the value of RAID 6 in terms of resiliency, and you can do so at a cost of RAID 5. So from a TV pitchman perspective, this notion of set it and forget it has some very specific value here in terms of setting it once across your storage environment means that you can rely on specific performance characteristics of the kind of RAID that you have and not have to worry about implementing different RAID sets. So one of the other things that you can do to improve the performance of the applications that you rely on is the notion of tiering your storage. Now this is a sort of a bridge on top of using something like different RAID sets, but what I'm speaking about specifically is that there are 2 ways in which you can tier storage. You can do it at the physical disk layer by buying different kinds of drives, fiber channel drives, SATA drives, SSDs, et cetera, or you can do it by expanding the cache. Now, a couple of slides back, I had mentioned deduplication at an intelligent caching layer and that there was going to be some value here and that we would talk about level 1 and level 2. And this is where that conversation gets started. Now, traditional arrays will use different types of disks to give you performance characteristics around that type. So you may choose a higher performing SSD, but you have to make that decision based on the characteristics of the I/O that's going to hit that drive. Heavy reads, SSD, good purchase. Heavy reads, heavy writes, a really deep, dense SATA drive on top of a RAID 5, lose one of those drives, let alone performance, the ability to rebuild that set and recover from a physical loss becomes a nightmare. But specifically to storage tiering itself, one of the things that I want to make sure that we cover is the effects that expanding your cache can have on the clients and the way in which they access them. From a numbers perspective, there's a specific array that we used that was a 3160. We used it with fiber channel drives. We used the same fiber channel drive setup, and moved it into a position where it was expanding the cache. And then we looked at doing the same thing, but using lower cost, deeper SATA. The goal for this particular test was we had an application who had an IOP requirement of at least 60,000 IOPS. I don't remember what the application was. It's irrelevant. The fact is what we were able to accomplish in terms of footprint at 3160, no fast cache or flash cache. What we're able to do is 16 shelves of 15K fiber channel drives to drive the IOPS that we need and give us an available capacity that was in the norm of what we were looking for. So when we did the same thing across the other 2, we dropped from 16 shelves to 4, and we dropped from physical footprint in the data center itself based on these changes. We were able to maintain more than 60,000 IOPS in each condition and maintain the kind of operational response time that we needed. But as you can see, in doing so, we were able to significantly elevate the available capacity by using deep, dense SATA protected with RAID DP and then tied with this intelligent level 2 caching system that we refer to as flash cache. Now, if you are a NetApp customer or were at one time, you may have known these as performance acceleration modules. So these are simply PCIe cards that would sit inside of the controller itself and extend that cache out. So caching is one approach that we can do for storage tiering. The second storage tiering approach that we can take is to actually use different kinds of drives. Okay? So one of the keys that I mentioned in here in using different kinds of drives is the fact that we can demux the way in which storage I/O is handled, right? So by separating out what parts of the drive themselves or what parts of the data themselves are high reads, high writes, and mixed workload, et cetera, we can pick different tiers of storage to place that workload to give the best overall performance to who's consuming it. Now certainly you can improve your reads by going with like an SSD approach. It's a little cost prohibitive depending on what your budget is like at roughly 20 times more than the cost of a fiber channel drive. You have to be very specific about how you're going to use those SSDs. So what I had presented to you in that 3160 comparison was the ability for you to up-level the ability to serve out what the client needs are regardless of the drive type on the bottom by using an intelligent caching system. So how does this look from a numbers perspective? So let's take let's take virtual desktop as an example. Take 1,000 virtual machines that are going to get deployed. So we'll use XP as the example here, and we'll use the approach that we're going to have multiple tiers of storage to support our needs. In this case, fiber channel hard drives and SSDs. We'll use the SSDs certainly to handle all the reads off of that master image, and we'll use the fiber channel to handle all of the writes. Okay, so in doing so, we can boot up at one time all of those machines within 45 minutes. So the only problem with what I just presented to you is they're not NetApp results. Instead, let's take that virtual caching or that virtual storage tiering that I had mentioned to you, and let's make some shifts. Let's go from 1,000 Windows XP machines and move to 5,000 Windows 7 VMs. Let's remove the need for you to go out and expend your capital budget on high-performing SSD drives and drop down to simple SAS drives and use that flash cache that I had mentioned. So 500% more in terms of VMs booting at the same time, 50% more of a physical footprint on the disks themselves that need to be accessed, results in a 5-minute extra amount of time that you need to bring all those virtual machines online. So pulling this particular slide back up and refocusing our conversation to talk about how these efficiencies affect the way that we deploy the infrastructure stack itself is pretty relevant. I had mentioned that the Flexpod, or the word flex in Flexpod, was the notion that you would be able to expand and grow your infrastructure in the most non-disruptive manner possible, let alone take advantage of situations where you have physical equipment that needs to run in tandem and ultimately get merged into. So again, based on top of Cisco validated designs, the focus here is that there are a myriad of different ways in which you can guarantee the SLAs, whether it's tiered applications, whether it's using OLTP databases, or in this case, the example that I use, virtual desktops. There's a design that's available to ensure that you're getting the kind of performance that you need for the workload that you're using. So let's kind of add a couple more pieces that we talked about and kind of pull these back together. So one of the features that I had mentioned that is available is this notion of secure multi-tenancy, the availability of you to isolate out the access of the component resources for whatever application it is that you're going to run. Again, a slide that I would imagine some of you have seen in the past, but what I'd like to do is I'd like to change that a little bit. So if you remember the C mode, the cloud mode conversation that I had, so now what we can do is use that abstracted layer of logic to provide support for these applications, including all the efficiencies that I mentioned, available to the users of those applications, not just the storage admin itself. What happens when you take on more work, either through M&A activities or you elect to branch out and provide different kinds of services? So in this case, I picked some pretty common random organizations that might need to get spun up very quickly. Well, again, it's simply just taking these V-filers, or whatever they're going to call them, which have been defined, which can be automated, and simply provisioning them out, adding the capacity behind it as we need to continue to grow the business. This is the elastic piece that I was talking about before. So I've just scaled out. And I've just done so using an infrastructure that's consistent in terms of the way that I manage, in terms of the way that I provision it, and now in terms of the way that I automate and orchestrate it. Now, to do that implies that we have key points of integrations. So I'm going to talk about those for just a few minutes. With the Flexpod product itself, you could certainly use the UCS manager, whatever networking switch kind of infrastructure manager you have, or even the on-command suite from NetApp. But because these are based on top of open APIs, one of the things that we can do is we can also offer out overarching management tools whether that's something that you're using today in your own environment or something that you may choose to purchase from a vendor, to give you the kind of management interface that matches your organization, to give you the kind of interface that ties very closely into vCloud Director, should you choose to start down that path. Under the covers, though, and working specifically with the hypervisor layer, the points of integration are prescribed by VMware. They come in the form of APIs. So from a storage perspective, I know them as the vStorage APIs for array-based integration. The other things that they offer is the ability for you to plug into the virtual center environment with logic that's very unique to your own organization. So I'll talk a little bit about the virtual storage console from NetApp. If you are in a position to where you want to use some of the APIs to even further enhance the array level management, there is the on-command suite as well, and I'd made a reference to that prior to this slide. If you need to take advantage of storage replication or data protection based interfaces, there is an API set available for that. And then rounding out this particular slide here is our ability to integrate with Site Recovery Manager, the APIs for array offloading, as well as anything in the future that VMware may choose to bring for non-block-based protocols. So as I had mentioned, the APIs themselves are a family. There are 4 of them. There is the APIs for Site Recovery Manager, for data protection, for multipathing, for those of you who use block-based storage, as well as the APIs that offload the responsibility of array-specific actions and alleviate the resources that would otherwise have been spent from a hypervisor layer to service out the virtual machines that are relying on them. Some marketing numbers. Again, I apologize for the buzzwords here a little bit, but it is important to know that you can get some very significant gains by moving into VAI-based infrastructures, where you're minimizing the amount of I/O it takes to do very common tasks. Okay, where you're increasing the amount of things that you can do with your storage and where you're deploying your infrastructure faster. And the APIs themselves come from VMware, so it's not like NetApp has secret sauce. The way that we implement the VAI is no different from the way that EMC would, or Dell would, or anyone else in this industry. So as you make those design choices up front, I would challenge you to ensure that the kind of infrastructure that you choose integrates if you are standardizing on VMware as your core hypervisor. Things like full copy offload, the ability for you to take I/O that would normally constantly have to traverse between the ESX environment or the vCenter environment and the array itself, and just simply tell the array, hey, I need you to do a full copy from this LUN to this LUN. Go. Let the array do the work and tell me I'm finished, or tell me when it's finished. Block zeros. I need to write a bunch of zeros out. There's no point in me, as an ESX environment, constantly sending a 0 down the stream. Just tell the array how many you need. Let it write it out. We need to lock a LUN so that we can create a database to do some kind of application snapshot, for example. And I've got other VMs running on that LUN. Why lock the whole thing? Let's just lock the piece of data that we need to work with. So what about integrations into the vCenter environment to create as close to a single pane of glass as we possibly can? So let me give you just a brief example of a pretty common set of tasks. So when that application administrator had gone down and asked the VM administrator for a new machine to run their application, the VMware administrator said, okay, great, so I need to know how I'm going to connect with the storage. Then I'm going to call the storage admin and tell the storage admin that I need capacity. Storage admin's got to create some LUNs. They've got to mask those LUNs. They've got to then talk to whoever the networking administrator is to make sure that we've done the appropriate level of configuration at the switch layer, et cetera, et cetera, et cetera. And this has all got to come back up to the VM administrator, so once this is all over, adding that LUN, putting an operating system on top of that LUN, putting a virtual machine on top of that LUN is now an option for that person. And then rinse and repeat. And you do this over and over again, it can be incredibly time consuming. So The virtual storage console is a great concept because what we're trying to do here is up-level the responsibility. The VM administrator works directly with your application owners and understands what it is they need to make their infrastructure work from the amount of storage required to support the application owners that are relying on them. So the ability to provision the storage should be made available to the storage or to the VM administrator. So you've just offloaded the responsibility of that storage admin and that networking admin to constantly get involved every time new storage is required, storage needs to be expanded, etc. When you give that top-down view of how the infrastructure is being supported from a storage perspective, you also begin to minimize the amount of risk analysis that occurs when there are problems. So now our VM administrator can talk to the storage admin using a common language set. So before it would have been, I've got a data store called X, and it's having a problem with one of its VMs. So now the storage admin has to figure out, what does X mean? What is a data store? So with something like the virtual storage console, now it's simply, hey, I've got a virtual machine that's sitting on top of a data store. That data store resides on a set of disks that's coming off this particular controller. I ran an analysis. The analysis shows that the data itself is not configured based on best practices from NetApp. I'd like to make that change. I just wanted to run it by you first. Going even deeper than that, being able to talk about the path at which that data has to travel to get to that particular LUN on the actual filer as well. All these kinds of vernacular that can then be shared intelligently between the two begins to minimize the amount of time it takes to resolve issues. A little bit of an eye chart here, but just an indication of the different kinds of interfaces that are available. So whether you're deploying virtual machines, using the VMware deployment technologies, or whether you are analyzing, imagine being able to take a data store. Now, you'd use the concept of block level deduplication. So imagine being able to take a data store that's not deduplicated because you're concerned about the effects of deduplication on top of the objects that reside there. So imagine being able to use this tool to right-click on that data store and perform an actual analysis so that the results that come back say, if you turn dedupe on, your estimated savings will be whatever they are. Would you like to do this? Right, so imagine now, instead of communicating with all of those people, simply ask the storage admin to provision up for you all of the storage that you are allocated. And using this tool, you are empowered to provision that storage out for the data stores and the virtual machines that need to use them. You've already had the conversations about getting the right kind of network connectivity between the storage and the compute. You've already had the conversations about how you're going to protect that information. This is where the power of enabling your VMware administrators with key concepts that they need to do their job comes into play. I mean, ultimately, we're all moving to the same location. Everyone is essentially becoming a generalist. As much as you don't want to, as much as you want to hold on to the notion that you specialize and have expertise in an area, more and more with the customers that I talk to, you have to know it all. And tools like this enable you to be proficient in all areas while still maintaining your levels of expertise. So I talked a little bit about shortcutting or minimizing or reducing the amount of time for root cause analysis. One of the other things that we can introduce is the notion of a product called Insight Balance, the ability for you to look from the application itself all the way down to the LUN or volume that's providing the storage for that application. Identify patterns and traffic that marks that particular path of data flow, that particular virtual machine, that particular ESX server environment as being a bully in terms of consuming more than is allowed for it. Giving you, again, the kind of vernacular that you need to consider making changes to drive a steady stream of efficiency across your physical infrastructure. So I got the 5-minute warning. I want to touch very quickly on business continuance. It's always an important factor. At NetApp, we're looking to unify the way in which we approach backing up, replication, et cetera. So not having multiple applications to do all of these things. Instead, let's begin to focus on the tools that you need to handle the replication of your information, whether it's replicating from one site to another, whether it's replicating at the same site itself. Well, what happens if your company is in the market for or looking to replace its traditional tape backup-based solution? So something like SnapVault is a great example. It's an alternative because it's using the same snapshotting technology that I was talking about to enable disk-to-disk incremental backups in your actual data, whether, again, that's on-site or off-site storage itself. And this technology is what we rely on for our integration into VMware's Site Recovery Manager. What about application-consistent backups? Again, with the Snap Manager product line, you can take advantage of that. There's support for different tiered applications. And my absolute favorite part is no longer do you have to buy a license for Snap Manager for Oracle and then buy a license for Snap Manager for this or that. It's just a Snap Manager suite that's application consistent, if you will, in terms of the way that you back up and protect your data so that you have a point of reference to come back to and know the exact state of the data. All right, so let's wrap this up before I get the big hook. So I've introduced some ideas that I'd like you to walk away with that have to do with the choices that you make in terms of the storage that you decide will support the virtualized environment within your environment. We've got folks who have done that as well, so some of the major vendors that we have who have chosen NetApp storage as the underlying technology for their as-a-service-based offerings are listed here. I always like those charts because none of them are here to help support what I have to say. So I'm really just showing you this to let you know that there are different levels of organizations who rely on the storage for the things that they offer. But the linchpin to truly implementing a cloud-based infrastructure does depend on those actual choices that you make. And I'll tell you this. Before VMware, or with the advent of VMware, on the commodity chopping block were the physical components. In the next 2 to 3 years, the chopping block will now have the hypervisor, because the focus of the way that you manage your virtual infrastructure will fall on the way in which you orchestrate and automate it. The hypervisor will just be a commodity as much as the storage, as much as the compute and the network. So when you make your decision about the infrastructure that you're going to roll with, regardless of who you decide, make sure that it allows you to scale out to meet your future and current demands. Make sure it has the efficiencies that are built in to give you the kind of response and resilience in that infrastructure. And I don't mean just storage. I mean across the entire stack. Service profiles, prime example for UCSs. I don't have to worry about how I provision the physical compute. Things like that are imperative to get you into a state to where you can rely on automation to put your users into the kind of control that they need to be more effective. Your user doesn't care about RAID levels. They don't care about fiber channels, SATA, etc. At the end of the day, what they want to be able to do is go to a location and say, I want to deploy Exchange. I want to support this many users with this average mailbox size. I want my data to be replicated every 30 minutes, backed up every 24 hours, and retained for 30 days. Go. And that's the direction that we're getting to. I am out of time. I appreciate you sticking around and not leaving when you realize you didn't win the MacBook Air. If you come by the NetApp booth and tell them that you came to the keynote, you'll get elevated in the selection for the iPad 2, but that may be a little bit of a stretch on my part. But again, thank you very much for sticking around with me. Thanks.